All right, folks, so we're going to get started here. We were so excited to see a ton of interest in today's panel, so thank you to all of you who are joining us today. I'm Max Black, an early employee here at ASAPP. I head up strategic accounts for us, and I have the honor of moderating this panel of folks who are frankly much more interesting than myself. So with me today is our own Ryan McDonald from ASAPP, as well as Jason Green and Jake Saper from Emergence Capital. And we have teed up what will hopefully be a productive and informative session around a topic you may have heard of, which is generative AI and the impact that it can have on transforming customer experience in contact centers. First, let me give a little bit of background on our panelist. Jason Green is a co-founder and general partner at Emergence Capital. Emergence's first investment was in Salesforce back in 2004. And since then, Jason has been involved in venture capital investing for over 20 years and has been a board member or advisor to more than 20 cloud computing companies. Jake Saper is a general partner at Emergence Capital. He's been working in venture capital and startups for over a decade with a focus on investing in SaaS and cloud computing businesses. And prior to joining Emergence, Jake was an investor at Kleiner Perkins. And then last but not least, Ryan McDonald is chief scientist at ASAPP and runs all ASAPP's research efforts. Ryan leads one of the largest AI research teams focused on enterprise in the industry. And prior to ASAPP, Ryan, you spent 14 years at Google. You led natural language processing research. And prior to that, Ryan completed his PhD work in AI at the University of Pennsylvania, also my alma mater. Last thing, hey, we want to keep it interactive today. So I'll lead the discussion for about, let's say 30 to 40 minutes or so. And along the way, please feel free, folks, to drop in questions into, I think it's the Q&A box for the panelists. Just drop them along the way. We will come back to those questions during the Q&A session at the end. And with that, Ryan, I will put you on the hot seat first, sir. So, you're no stranger to this topic. You were on one of the early teams at Google working with large language models. So let's just start with the basics for folks. What are LLMs? What does it stand for? How did they come about? What are they capable
of? Well, thanks, Max, and thanks everybody for having me. So before I get into that, I wanted to just kind of open up a little bit with that. I think LLMs, large language models, generative AI, where we are today, it is a really big deal. I've been in the field for over 20 years. When I first joined Google, AI was sort of a little niche thing that people studied. By the time I left, it was in every product. But I think we're at this point, certainly the progress in the past few years where, the capabilities have grown tremendously. And I think it is an inflection point in the field, in many fields. But before we get into that, let me just get to some basics. What are language models? What are large language models, generative AI? A language model is basically any model or system that will predict a word given a sequence of input words. So if I say something like, the cat sat on a language model would predict something like mat or roof or something fence, something like that. We call these generative models because we can use that power to sort of generate whole sentences, whole documents, just keep generating word after word. And these models have been around for a while. There's a long history of generative AI and large language models that date back 50, 60, 70 years. Back then, people wrote rules to sort of tell the system what word to say next. But it really took off, I would say, in the 80s and 90s with statistical or corpus-based language models, work in automatic speech recognition, machine translation, particularly the work at IBM in the early 90s on those two topics, really sort of took it from the periphery to a core technology that people used every day. And that drove innovations like Google Translate or Alexa that use these kinds of technologies and have been using them for a while. The difference between that and today are, I would say, three things. One is we now use a neural network to make the prediction of what word comes next. In particular, almost all large language models use something called the transformer. And that was developed by Google about 4 or 5 years ago. That's the T in GPT, transformer. The second is we train them on huge amounts of data, tons of data, the whole web. And the nice thing about language models is, since they're just predicting the next word, we can take any raw text data that we have and feed that in the system to learn what words come next, given some context words. And that's the PT. They call this pre-training of the model in GPT. And the third is the size of the model. So it's a neural network. I like to think of it like a building. We add more floors to the building and we increase the square footage of every single floor. That's like adding more parameters to the model, and it has more capacity. And so when it has more capacity and we feed it more data, it can sort of memorize more about the information that it's seen. And that's what gives it this kind of like amazing background knowledge that it can then act on. And so what are they capable of? Obviously, they're capable of predicting the next word, but we found that they can do much more. And to think about this intuitively, if I gave you an article about the Yankees playing the Red Sox, and then I gave you a sentence that said, this article was about the Yankees, and I said, complete that sentence, Yankees, Red Sox, baseball. There's lots of different ways you can complete it. But just using a language model, we have a way of categorizing the document. We can then sort of say like, well, okay, if, categorize or think about these topics, sports, politics, and religion. This article was about, and then you would say sports, and the model would say sports. So we've gone from a model that can predict the next word to, by prompting it in the right way, and this is what we mean by prompting it, sort of manipulating the words that we feed into the context of the model, we've now created a document classifier from that model. So language models have that power to do much more than predict the next word. So yeah, that's kind of language models in a nutshell.
Got you. Yankees and Red Sox. I thought you were a Phillies fan, Ryan. So that's a little bit shocking there.
I'm actually a Blue Jays fan.
Go Giants.
Good job. Okay, there we go. So it's going to get controversial. Jason, so back on the topic, we've been fortunate to count you and your team at Emergence as key investors in ASAPP for many years now. And Ryan used the term inflection point. So this is a new disruptive technology coming into the market. You're no stranger to times like these. So, with the experience that you've had at Emergence, how have moments like this shaped your investment strategy over the years?
Max, it's a pleasure to be here. Ryan, great to see you. And, we're super excited to be partnering with ASAPP. And as for context, I think it's important to know, you probably haven't heard of my firm, Emergence Capital, but you definitely have heard of the companies that we've invested in. And the firm was founded back in the early 2000s. In the aftermath of the internet bust. And, there'd been a huge hype cycle about the internet and a lot of unrealistic expectations about what the internet was going to become. But at the same time, there was some real value being created. And the key was to figure out which opportunities were real, which were hype. And I think Emergence really, at the end of the day, distinguished itself by focusing in on the category and really picking the winners well. So our first investment was a company called Salesforce.com, which I'm sure you've heard of. Was a small company at the time, has gone on to be really a leading company in the space. And I'm really proud of the fact that we focused the firm in the category and stayed disciplined on kind of trying to pick the big winners in the space and become an important partner to them. So we went on to invest in companies like SuccessFactors, and Box and Yammer and Zoom. And we were just so fortunate to be working with some incredible companies and building companies that really had a big impact on productivity and success in the enterprise. So I think what is important just for context is to know that our firm really focuses on one category, enterprise cloud and software. And we do our best job of sorting through literally thousands of companies that are started every year to find the 10 or 15 that are going to be the really important companies. Many of them over the cycles that we've looked at have similar characteristics, the ones that really break out. And I think it's important for us to really note that, the companies that have emerged as the leaders, first of all, are identifying this thesis and really kind of digging in on trying to find a unique and compelling value proposition in that thesis. Have a product that has a really compelling solution to customers such that I call it customer love, the customer love quotient, which is really high. So it's not just customers that are buying the product, but truly love the product and see value. And then finally, have an extraordinary team that is very ambitious about what they want to tackle. And if those things are there, we tend to lean into those companies. ASAP clearly was a company that distinguished itself on all of those fronts. And we've been really fortunate, again, to be partnered with some of the leading companies in the space over the last 20 years. And we know ASAP will be one of those companies mentioned in the long run in the history books of jumping on that a key thesis and a key trend and really distinguishing itself.
Fantastic. Thank you, Jason. Jake, you have, I mean, speaking of picking winners, right? You've thought a ton about how AI within Emergence can impact enterprises, and AI has shaped your investment thesis in terms of what companies you've chosen to be involved in, and that's been to great effect over the years. You know, maybe you can help us initially with kind of the scope here of generative AI, large language models, like what types of businesses should be using LLMs? And, you know, how broad are these applications? Are we talking about every sector, or is it a little bit more narrow? Curious to gain your thoughts.
Yeah, thanks, Max. And I'm excited to be here as well. LLMs are applicable anywhere there is language. And so the applicability is quite broad. There are questions around how to deploy them effectively, and I have no doubt we'll get into those conversations through this through the course of this webinar. But we see companies doing really exciting stuff with LLMs in the legal space with contracts. We see companies doing exciting stuff in the workforce management space with this technology. We see companies doing exciting stuff in knowledge management. We see companies doing stuff in the medical domains. And of course, a number of companies, most notably ASAP, doing exciting stuff with this technology in the support stack. So the applicability here is quite broad. The question is, how do you deploy it effectively?
Yeah, for sure. And the broad applicability is manifest. In LinkedIn, I see practically every hour, yet another AI application of transformers and these types of technologies coming to the fore. I mean, Jason and Jake, I have to assume that, you know, in your meetings with portfolio companies and prospective investments, the term generative AI is popping up more and more. And, you know, Jake, you alluded to kind of a more thoughtful approach. It's not a technology that can just be broadly deployed. It needs to be thoughtfully deployed. So how do you distill the signal from the noise? At Emergence, what are y'all seeing across your portfolio in terms of application of the technology where it's a thoughtful and actually interesting application?
Sure. So thinking about the structure, I guess there's a couple dimensions we think about when we're evaluating a potential investment that's using generative AI. The first is simply the team. What is the credibility level of the team? How strong is the research talent and the AI talent behind it? How strong is the leadership? So that's obviously really important. And we also think really critically about how the company is applying AI, and are they doing so responsibly? The technology is advancing very quickly and has a very famous tendency to what's called hallucinate, which means give you answers that are not the correct answers. So we prefer to invest in companies that have architected their software in such a way that those types of hallucinations are minimized. And often that involves some sort of human-machine kind of co-pilot or synchronous design.
Yeah, the only thing I'd add is when we're kind of doing the homework on whether to invest in a company, a lot of folks sound the same. You know, we hear thousands of pitches where everything sounds the same, and so you really got to dig under the covers and really understand what the nature of the technology is. And we also do a lot of homework on talking to customers, frankly, and seeing the impact that the technology has. And you know, we think this term product market fit is really critical, which means that you have a compelling solution that's solving a real problem, and customers can really speak to that value proposition. So it's not just about, you know, hand waving and terminology. It's about, have you actually made a difference in people's businesses? Have you increased sales? Have you reduced costs, provided a way to build a competitive advantage or a competitive moat? So that's when we get excited about opportunities. And it's sometimes hard, you know, to differentiate between the hype and the signal, but you have to do the homework.
Right. And have you actually built a holistic product that comprehensively solves a problem for a business user, rather than just, here's an LLM responding with, you know, based on some context with a message? So Ryan, the buzz around generative AI and large language models has obviously grown, as we've been talking about. But the technology, like this technology has been around for some time. And as you know, at ASAPP, we've been applying generative AI, large language models within our space in the contact center since, let's say, 2016, give or take. But obviously, OpenAI has helped make these concepts mainstream now. So why is this happening only now? What did they do differently to bring it to the collective consciousness?
Yeah, that's a great question. Yeah, so I mean, as you said, these models have been around, the neural network architectures, language models, in all sorts of forms, have backed ASR systems, translation systems, personal virtual assistants, search, ad placements, whatever. They've been around and people have been using them. At ASAPP, we use them for real-time agent recommendation systems, what to say, what to do next, summarization for disposition notes, our virtual assistant, and even offline analytical use cases. We would use these models. But yeah, there was this big event last fall. ChatGPT was released, and it got a lot of traction. Sort of allowed people to realize, that these models aren't just sort of an academic exercise. There's a lot of value to be pulled from them. And I think they did two things which led to that. The first is the UI. They just made a great UI. It made it very easy for people who weren't experts in the field to go in and play around with it. So people who run call centers or are lawyers or medical doctors could kind of go in and play around and understand where they could extract value from a system like this. And I think that helped a lot to sort of lowering the barrier to people sort of believing and getting on board with generative AI. The second one is learning from human feedback. So even before ChatGPT, OpenAI and others have been looking into this idea of instruct tuning. And so this is this idea of how to train a model to follow instructions. So historically, we would train a machine learning model to complete a task, like train it to classify documents, whether they're sports, politics, or religion, that sort of thing. Very sort of one task, that's it. And a few years ago, we started as a field looking at, well, how do we just train models to follow instructions, even for tasks that they haven't seen before? And so this is this instruct tuning general area of research. And OpenAI, they have a method for doing that, but they employed a lot of people, a lot of humans as sort of, biologists, lawyers, medical practitioners, chemists, what have you, to sort of prompt the model with questions or instructions from various domains, and then grade that. And they learned to sort of take that information and put it back into the system. And they did that at a huge scale. And so this allows these large models to not just memorize information and put that in the parameters, but also learn how to pull that information out of the parameters to execute some task. Even things as far-fetched as, write me a poem about the Civil War. So this was very important to sort of give it the power to follow, in some sense, arbitrary instructions. And it's sort of a big horizontal model in that sense. It's been trained on a bunch of different domains to follow a bunch of different instructions. And actually, again, like I said, this idea of human in the loop feedback, instruct tuning, has been around. And even at ASAPP, we've been building models that do this for a number of years. But instead of at this sort of general, all tasks being considered case, agents who are looking at the predictions of what to say next, what to do next, or summaries are interacting with those. And that is feeding back into the system in sort of a continuous virtuous loop to make the model better and better over time. And so that's an example in the call center of how this can be done to make the system better.
Yeah, and you and I haven't talked about this notion of reinforcement learning through human feedback. I mean, within the context of ASAPP in the call center, we have agents who are experts, who are above the pack in terms of SCR and CSAT results, and the machine learning models learn from the outcomes that they generate in order to improve. Within what we've seen in GPT and what OpenAI published, you talked about some of the experts that went into training the system, lawyers and biologists and so forth. And then they have more general reinforcement learning through human feedback. I'm just curious what you think around, the exposure of the model to a general populace of folks that actually may not be experts versus, folks who are actually skilled in that field? I'm curious to comment.
Yeah, I mean, I think that's a good point. But I think there's also something even more subtle happening. If I just took you and I asked you to train a model, you would start coming up with prompts or questions you might ask the model. And if you're a doctor, maybe you'll think of things that you might ask during the day or whatever. But you're kind of forced on the spot to think about that information you're going to put in the model. Whereas if an agent is doing it, they're not even aware they're doing it. They're just interacting with the predictions of the model and how they select it and how they edit those predictions are being fed back into the model. It's much more natural. We're not sort of putting them in this situation to make up information in order to train the model. It's natively happening during their working day, during the task they're trying to solve. So that's kind of a natural feedback loop, which happens a lot in many different recommendation systems. It's a common paradigm. And that's a much more powerful signal because you are learning to the actual, working environment of the person who is using the model, also often with knowledge of the outcomes that are happening based on how they're interacting with the model.
Right, and on that topic, you've talked about, okay, some of these LLMs are horizontal generalized capabilities, predicting the next word with other applications. What you just talked about there, is that what verticalized AI means? What's the difference between horizontal and verticalized AI? Is it just the training data set? Is it the entire infrastructure around the application? Maybe speak a little bit about that.
Yeah, definitely. So it's much more than just the model itself. So when I think of horizontal versus vertical AI, horizontal AI, I would say, are these open source, these publicly available APIs that have been trained on, all sorts of data, the World Wide Web. Maybe they've been trained to follow a number of different tasks across a number of different domains. They're kind of jack of all trades. They do a good job generally based on any query that goes in. And actually, it's kind of not surprising that for things like consumer products, so search or writing assistants, this kind of thing, they're quite powerful, right? Because they're just kind of taking something like a search system and bringing it up a level, right? They're taking all that information and they're doing very intelligent things with that. And that's kind of what I talk about, going from apps with maybe narrow use or narrow input methods to things that are going up a level to much more complicated interaction modes. Vertical AI, on the other hand, part of it is the model, part of it's the data, right? So I think of vertical AI really as fit for purpose, and that means different things. So on the model side, obviously it's trained on the domain data. For us, for the call center, it's our customers' data, maybe the vertical, the industry that they're working in. So the model is specialized to that data. It's a big part of it is actually being optimized on the business outcome, right? So large language models, generative AI, these are optimized to predict the next word, which is great. And actually we can do a lot with that, as we've seen from these open source tools. But at the end of the day, we want to sort of return on a business value, whether that's increasing CSAT, improving first call resolution, whatever that might be. We want to optimize the model for that. And that can be complicated. That's not often a trivial thing to do. So the model is part of it. But another, I think, very underappreciated part of it is the ecosystem in which that model is going to live and is going to be interacted with, whether that's by the customer or the agent themselves, right? They have a user experience when interacting with model that has a UI, also has things like latency constraints. The model has to sort of return fast enough for them to act on any information that they need to execute a task or what that might be. And then, of course, data, telemetry, measurement. This goes back to business outcome. How do you kind of set up your data pipeline, your telemetry pipeline, so that you're getting the information through the system, not just to make accurate predictions, but so that you can set up this virtuous feedback loop as people are interacting, agents, customers are interacting with the model predictions. We can feedback that back into the model and make it better over time. So it's getting better at executing these tasks, at suggesting things to do next, how to resolve problems. The example I like to give is a product that we actually call autocompose. So this is a product where we tell the agents it's meant to sort of reduce crafting time, how long it takes an agent to type a message in a digital conversation. So it suggests what to say next, either a whole message or as the agent's typing in line, things like this. We found in the system we built, we can automate or augment up to about 70 or 80% of messages. That means about 7 out of 10 messages the agent doesn't even have to type. They just select what the model says. That reduces handle time quite a lot, 180 seconds to 100 seconds per interaction in some case. And what we see when we do analysis, that obviously the model plays a big role in that. But when we look at cases where usage makes huge jumps, this feedback, the model getting better over time, definitely you see increases. But things like improving the latency or improving the user experience or adding a new feature or giving the agent some tools to customize the messages that they're going to see, these lead to like really large jumps in interaction time. So that optimization for the business outcome is certainly on the model part, making the model better, but also thinking about this whole ecosystem is critical in that space. And for me, that's vertical AI, right? It's
Right.
the AI, the model, it lives in this ecosystem, and you have to think about the model with respect to that.
Right. So like to effectively verticalize these capabilities, specifically for contact center, for example, it's not just about, well, let me train it on a specific data set. Let me train it on my historical conversations. Well, if the task is to use generative AI to suggest responses to agents in real time, it's actually a whole ecosystem of capability that you need to build around the LLM, which is kind of one component. And Jake, on this topic, you have actually a really interesting take that I got the opportunity to read the other day. Folks should listen in on it, on the limitations of AI, horizontalized LLMs, and the automation that they create. And you developed a thesis at Emergence around this thing called coaching networks, where, suffice to say, as we've just talked about, LLMs are not a panacea. So can you talk a little bit about what the thesis is there?
Yeah, and the product that Ryan just described is a great manifestation of the coaching networks thesis. But at the highest level, the idea behind coaching networks is using data to coach workers in real time on how to do their jobs better. And the idea is you learn, for example, a customer asks a question and an agent responds in a certain way. The system learns what the agent's response was, and then it correlates with business outcomes, as Ryan mentioned. So, how quickly did that ticket close? What was the customer NPS, et cetera? And then can learn the correlations between those two things and then make recommendations for everyone else in the network that has a similar question going forward. And so in that way, the very usage of the product makes the product better and better over time. So the more people you have using this over a longer period of time, the better and better the business outcomes effectively. So these are really powerful business tools. Like you get true network effects with this concept because of this kind of data human integration. The other huge benefit from this model, from this approach, is you minimize hallucinations. You minimize issues that would actually take place. So one of the big dangers with using LLMs in the enterprise is they could be wrong. They can sound right, but be wrong. And anyone who's used ChatGPT, and if you haven't, you should, just log on and create an account on OpenAI. You can experience what that feels like, where you ask a question and it confidently gives you the wrong answer. In enterprise, that's not okay. And so we think this coaching networks approach of having an LLM that gives an answer, but that having a human in the loop that actually qualifies that answer, edits, improves, et cetera, ensures accuracy, gets you to a better result. The other thing I'd say is when you train on a vertical data set, as we talked about before, the odds of hallucination happening are actually lower because it's more specific to the answers that your customers are dealing with.
Yeah, so these models become much more powerful as they're optimizing, not just for predicting the next word in the sentence, but for some specific business outcome. And the coaching network is all of the folks who are, collectively attempting that task and training the model as they work, or helping to optimize for that outcome. Ryan, this notion of outcomes can get a little complex in the contact center. You've got some folks who work on retention, some who work on servicing and support, some who work on sales. the business outcomes, the KPIs that matter in those different domains are kind of different. Maybe talk a little bit about the outcomes piece in the context of the contact center. What are the metrics that matter? How does a model account for those?
Yeah, I mean, as many people here know, there's a lot of different metrics, and it's depends on what you're trying to do: handle time, FCR, throughput, CSAT, time to proficiency. I can go on and on and on. I think that the interesting thing, though, is that sometimes these are hard to measure. When we're training machine learning models, we need to optimize for an outcome, so we need to measure it. And these things are just sometimes hard to measure. CSAT is often sparse. FCR, unless it's explicitly recorded in the metadata, it's implicit. Did the customer call back in the next day with the same issue or something like that, right? Handle time is great. That's often, you can just read it off the logs of a conversation, but it's kind of awkward for a machine learning algorithm to be optimized towards it. So, one thing I really focus on is measurement. How do we map from those business outcomes we care about? How do we get those measurements in the first place? And if we can't, what are good proxy measurements that we can sort of optimize the models towards? And this is critical to getting it right. And actually in ASAP's research group, half the group is data scientists because we think this is extremely important. So like a good example might be something like CSAT or FCR. I mean, like I said, they're either sparse or they're not in the data. So you need to create models that predict on conversations, was the customer actually satisfied or a survey, or do we think they actually called in with the same issue later? Handle time will do things that create proxy metrics. So for instance, auto-compose, telling the agents what to do, what to say next. We've done a lot of analysis to understand, like, well, every time they click on it, they save 18 seconds, or if they use another feature, they save 10 seconds or something like that. So we can map usage of a feature to something like handle time saving. And then you get into a nice spot where you can optimize for that. We know how to optimize for usage. This is typical recommendation systems, and theory there has been around for a long time. And so like knowing what your outcomes are is important, but equally important is getting that measurement right. And that's data, but that's also knowing how you can optimize a machine learning model for those outcomes, and whether you need to create proxy metrics or other things to get there. And that can be tricky. That's not necessarily the easiest thing to do.
Right, where in a situation where you're optimizing, actually, you might be optimizing for both improving efficiency and improving quality at the same time. Can these AI models, which are optimizing for different tasks, balance across those types of KPIs?
Yeah, no, absolutely. Again, if you have any KPI that you can optimize a model for, you can balance multiple of them in what we call an objective function. And I think this is where some business logic or priorities come in. How do you want to balance them off, right? Which is more important to you? And getting that trade-off right is not, a machine learning problem. It's a business problem and requires humans to sort of, put value propositions on top of it.
Yeah, for sure. So, there's been, Ryan, this kind of gold rush towards these types of capabilities. Large language models, generative AI, everyone knows the technology has broad applications that are impactful, but it's also kind of a minefield. Like we've seen this with, in terms of, the risk of intellectual property theft, security risk, compliance risk. Jake, you talked about, if I'm running a bank, if I'm running an insurance company, healthcare, I need to be compliant. I can't be hallucinating information in these conversations. AI bias, ethics. How do we build these types of systems, Ryan, in kind of a thoughtful way? You've talked about this concept of last mile AI, where we're not only optimizing for business metrics, but we have checks and balances within the system to ensure to absolutely minimize the possibility of things where we're exposing the business to risk. How do you and your teams and the products that you build within ASAP, how do you guys think about controlling for that?
Yeah. So last mile, I think, to me, that's a broad term. And like you said, last mile is sort of taking the model that we've trained and putting it in that ecosystem. And everything I talked about earlier around the user experience, tooling, what have you, in order to make sure that you return on the business outcome you want to return on, and not just have a fancy machine learning model at the end of the day. And like you said, part of the last mile is mitigating risks that come with generative AI or machine learning altogether. I think Jake talked about this. Human in the loop has lots of different advantages. The first is, of course, models can get better over time. Humans are naturally, like I said, naturally training these models by interacting with them. And as they get better, more usage, maybe the human has to intervene less. But a really nice byproduct of that is it does add a layer of safety. If a human is, while coaching the machine, they're also acting as a gate to information that's coming out. I mean, that said, humans are fallible as well. If a model's giving information to, let's say, an agent who just joined a company, they might not be aware that the model might make a mistake and that the information that they've been given doesn't have, the highest veracity, as it were. And so you do need other balances in there. And so our team, we work a lot on reducing hallucinations, also something we call data leakage or domain leakage. When you have large language models, you may get information from one domain leaking into another domain, or from one customer potentially going out, depending on how things are trained. And we've done a lot of theory and a lot of modeling work to sort of mitigate that, basically making training schedules, balancing private versus sort of public training, and simple things like redaction, in order to make sure that we can put some theoretical guarantees on how much information does leak from these systems. But ultimately, that last mile, the game is about mitigating that as much as possible.
Right, and introducing functionality that's kind of easy to use and intuitive for a supervisor, for an agent, to accurately train the system in terms of teaching it what's correct, what's effective.
Yeah, and I think like what you said, it's teaching the system is important, but the tooling is important as well, because it gives agents, supervisors levels of customization, to kind of put in responses that they want to use, or put in safeguards around how much information the system's allowed to generate versus take verbatim from a knowledge base or something like that.
Right. And we've seen at ASAPP how important a UI that's easy to use and intuitive, which is architected in a way to learn through usage and interaction, how important that is to this whole process. Jake, one for you, back to coaching networks, the thesis there. I wonder, maybe project out the future a little bit for us in terms of the effect of the concept of coaching networks, the automation that these kinds of technologies can bring, the effect of it on the contact center, if you could project out. And you've talked about, the extent to which these types of tasks can be completely automatable versus we need to have a human in the loop. I wonder if you could talk a little bit about that.
Yeah, the way to think about it is like you're giving your agents superpowers. And the superpowers will allow them to do two things. In the one case, the more repetitive the task, the more likely that task will be automated or just have a very light human touch that just approves what the machine says. It then frees up that agent's time to deal with the more complicated issues and do a really good job, as well as think about potential upsell, cross-sell opportunities. As we all know in the call center, the opportunity for turning it more into a revenue-facing place than just a cost center is a very exciting opportunity. And we think these coaching networks concepts, deploying LLMs in the right way, unlock more time and capacity, as well as potential creativity for these reps to learn from each other in this process of creating more cross-sell, upsell.
Yeah, and Jason, I wonder if you would comment if you've seen that, in terms of the value of transforming the contact center from a cost center into a revenue center, where you're mining these conversations for insights, you understand how to identify and remediate churn, prevent churn with customers, and identify upsell opportunities. For you to comment on the kind of value there and how enterprises should be thinking about that.
Yeah, I mean, as Jake pointed out, it's kind of the best of both worlds. You kind of let the machines do what they're best at, and then let humans do what they're best at. And I think this idea of freeing up the agents to be more empathic with the customer's issues and problems, to maybe even come up with new ideas or new solutions of how to solve those problems, and then have that feed back into the model. Again, that's the kind of this learning network, this coaching network that you're trying to create. And we've always believed kind of the power of the machine and humans is always going to be more powerful than just a machine or just a human. It's how do you take the best of each unique strength and then marry them together in a really powerful combination. So I actually think that, we've seen a few of these cycles come through in terms of, cloud software or mobile or social, but this one really has an opportunity to, as Jake said, to supercharge human capabilities in a way that we haven't seen before. It's a really exciting time to embrace this shift and this change.
Yeah. Ryan, maybe make it real for us. I mean, what has gotten you excited in terms of results that we've seen? What does good look like as far as, we talked about auto compose a little bit. We're doing, real-time agent assist and generative AI across voice and digital interactions at ASAPP. What does good look like? What results have gotten you excited?
Yeah, sure. Like, I guess there's business. I mentioned some outcomes earlier in terms of, for auto compose, augmenting up to 80% of messages. We've seen also that helps with sort of first time to respond. So as quickly as the agent gets to the customer, and of course that's like highly correlated with CSAT, and that plays out in the results. For me, what gets me excited, there's a lot of things that get me excited. But one thing that I'm seeing now come to fruition, and generative AI and large language models help us do that, is we can make them multimodal. It's very easy to sort of make these models operate on more than just text. And for the call center, that's important, right? If we're just looking at conversations and we're just looking at the language aspect of language models, we're sort of limiting how much we can help the agent or what we can do. In some of our customers, we see that agents can actually spend 60% of their time outside of the conversation in other tools. And so you need to have sort of a 360 view into all of that action data, all that telemetry data. I call these agent models because they're looking at all the action data, that agents are executing on behalf of the customer, moving information from the conversation over to tools, information from the tools back to the customer. And we're now at a spot with these large language models and generative AI where we can make them multimodal. So we have agent models that are both action and language data, and we can really sort of bring it up a level from just, what should you say next or do next, but based on this data, learn to sort of execute on behalf of the agent or the customer for that matter, certain actions, and really get this 360 view to push the needle in terms of what the augmentation and automation can do in these conversations. And I think we've done a bunch of work here, and you can probably tell I'm very excited, but I think we're just scratching the surface and really getting at that other part of the task the agent does is super important.
One of the most compelling, sorry, Max, I was just going to mention one of the most compelling things I've seen relative to the technology too is this ability to kind of shift between both chat and voice and to kind of have that continuity between those modes of operation. I think as a consumer, there's nothing more frustrating than, going down the rabbit hole and providing all this information and then starting over again, right? With the next thing. And I just found that to be really compelling experience to be able to kind of shift between those and have essentially the company remember everything that's of that interaction and bring that to bear on the next interaction with that customer. It's such a more powerful way of dealing with customers, I think. So.
Yeah, and to be able to arm the agent with in situ contextual recommendations, whether it's digital or voice, so the customers have to start over, which is one of the worst things you can do in customer experience. And it's inspiring and exciting to see, applications of generative AI beyond just bots. There's so much we talked about with respect to what it can do for agents to serve customers and drive these revenue outcomes as well as supervisors. So there's a lot to do. There's a lot of exciting applications. Jason, one last question for you, because I remember so many field team kickoffs where you emphasize the importance of customer success. which I was involved here at ASAPP early on. And you taught us it's not purely about deploying fancy new technology. You have to ensure that these companies are ready to adopt new tech. And we probably have people on the call who are change agents in their own organization. So how can businesses lean in to make the most of this?
Yeah, so it's a great question, Max. We think a lot about trying to make sure that we're investing and supporting companies that are fundamentally aligned with their customer success. And that comes from a few things. One is, you want to basically pick a partner that's a trusted partner that's going to help you accelerate your own learning in the space. And frankly, even having webinars like this, I think this says a lot about the company. We're trying to bring the best of our thinking to help our customers get smarter, okay? Secondly, you got to be aligned with customer success. And a lot of that comes from the business model. And I think one of the things I love about a lot of the companies we've backed in the past, including ASAPP, is we're aligned with our customers' success. We get paid when we create value. It's not like the old enterprise software world where you charged a bunch and it was like up to you to get the value out of it. So the more success our customers have, the more success we have. And I think that's a beautiful, virtuous cycle. And then finally, I think it's really important to, embrace the change here. And there's an old saying, you never get fired for picking IBM, but you never get promoted for picking IBM either, and in a world of increasing pace of change and volatility, it's the folks that adapt to those changes that thrive, right? I mean, we've learned this as humans, right? Adaptation is our greatest skill. And so kind of embracing the change, accelerating your own learning, and then picking a trusted partner who can help you accelerate your own learning and it is aligned with your success. I think that is the key to leaning in, and you can't go wrong on that front.
Love it. Awesome. Well, this has been a fantastic discussion so far. I think we do have a little bit of time for Q&A. I know folks have been dropping some questions into the chat, and I have a handy dandy document here to help. So first one is for Jason or Jake. How quickly do you anticipate the common customers like us, expecting generative AI in digital experiences? And how does this pace of modernization correlate to previous technology advancement trends?
I'm happy to take a first stab at it. So two separate questions. On the kind of what is the consumer expectation? The consumer, I think, is expecting a great experience. How it's delivered is the question of the person delivering it, not for the consumer themselves. So whether or not the consumer is getting that great experience through generative AI, through a combination of generative AI and a human, or just through generative AI-led automation, is really irrelevant to the end consumer. But the consumer's expectations for the quality of their interactions with their vendors is going to increase because this technology is going to make it better and better. In terms of how to contextualize this rate of change versus other technology changes, this has been insanely fast, faster than any technology change I've ever seen. If you look at some of the adoption of some of these tools recently, they've been adopted faster than Netflix was adopted, faster than Instagram was adopted. So if you just think about folks' willingness to engage with this technology, it is the curves are kind of mind blowing.
Yeah, and it's important to consider again. Consumers are not going to be sitting there thinking, "Hey, I really wish this thing would be generative AI as I engage with it." They're looking for a seamless experience. They're looking for the outcomes that matter to them. So it's important to kind of consider that it's. Go ahead.
No, I think, Max, I just wanted to point out though that consumers' expectations are established a little bit by their experiences with consumer products, right? And I think we learned this in the enterprise software space where, when people started using Google and Amazon and Yahoo, all of a sudden the way they interacted with software at work, their expectations changed. And I think we're now, the open AI thing is a Netscape moment. It is an iPhone moment. I think there's going to be a material shift in the way that consumers have set their own expectations of how software gets to know them and is personalized and is thoughtful about those interactions. So while they don't know how it's delivered, I do think there's going to be an increased ratcheting expectation about how intelligent companies deal with consumers. And So that I do feel is significant. Like, and it's really in the last 4 to 5 months that we've seen this kind of threshold change. And I agree with Jake 100%. The pace of acceleration and adoption here is unlike anything we've seen in the past. And I don't know whether it's just because information gets communicated more quickly out there with these all these social media platforms, but yeah, the pace is kind of breathtaking to see. Literally every week, new innovations and new products are coming out. So it's yeah, it's an exciting time. It's a scary time, but it's an exciting time as well.
Yep. Hey, this is an interesting one that came in. What and Ryan, maybe you take a crack at this one. What does the panel think about using OpenAI/Bard, a centralized capability, versus training your own model for your own industry, almost kind of like a more generalized buy versus build? Ryan, what's your point of view there?
Yeah, absolutely. I think you know, OpenAI versus, you know, train your own or something like that is not the dimension that I would actually think about, you know, a huge amount. In some sense, for me, there's OpenAI, there's Hugging Face, there's these tools that, whether it's an API or some open source tool, these are like tools in your toolbox to try to solve these problems. When thinking about, should I build myself with OpenAI or you know, use an expert like ASAPP that builds these things, to me, I would think about what I mentioned earlier, connecting this last mile issue, connecting a machine learning model to an actual business outcome is very non-trivial. A lot of that has to do with not just training the model at the beginning, but getting the data right so that you can continuously optimize, making sure that what you're measuring and optimizing for, not just next word, is actually the business outcome you care about. And all of that sort of machinery is in some sense more important than the model itself. The model's important. I don't want to, you know, de-emphasize that, but that other machinery is extremely important as well. And I think if deciding build yourself or buy, think about that aspect. Do we have the expertise on the data pipeline, on the measurement pipeline, and the AI pipeline? You know, prompting OpenAI to get a good response is a lot different from being an expert in machine learning. And does the company have that expertise to really do that last mile to go from the model to the output? That's kind of the dimension I would think about there.
One other thing I'd point out there, early on, I remember folks really questioning the security of cloud software. You know, Salesforce.com wasn't, you know, they just questioned, was it going to be secure? And what ultimately people realized is the amount of talent, resources, engineering that went into protecting Salesforce's system, because every customer was built on the same system, was an order of magnitude greater than any customer could do themselves. So it was actually a more secure place, right? And I think the same is going to happen now with these models where, you know, you can build some internal capabilities and certainly, you know, iterate from them, but you're never going to achieve the level of depth of the team and the quality of the team that Ryan has built to kind of squeeze the value out of this technology, make it secure, make it safe, and make it productive. So I think it's important, again, time to learn, but also pick your partners in this trend.
Yeah, for sure. And that's a great segue actually for another question that came in about prerequisites, kind of, okay, what do I need to do to make this technology successful? Jake talked about, you talked to Jake in Coaching Networks about my own contextual data and context and telemetry informing these models. That means I need to put in data. I need to expose APIs to these systems so that they're more effective. Ryan, I wonder if you could talk a little bit about what does an enterprise need to have in place to make this successful? If they're not building the LLMs themselves, they're trusting a partner. What we've seen the gamut of, I've got no APIs and I have a ton of data and rich API capabilities. Talk a little bit about the prereqs.
Yeah, absolutely. And I probably sound a little bit like a broken record here, but get your data and your measurements in place, right? So whatever that is, make sure that that's your telemetry is good. You know what you want to optimize for, and you know what you want to measure, and that's kind of first step. So that has to do with more like, well, how can I get the information into the models in order to sort of extract the quality, high quality predictions for what I want to do. But then there's a bunch of like operational aspects about it, right? And I think there's kind of two dimensions there. One is, I think Jason just said it, like security. Depending on what you're using, if you're using an API, what's happening with that data? Is it properly redacted? Making sure that you have the right processes in place, redaction being the sort of most obvious one that comes to mind, to make sure that you're okay to move the customer data around in those ways. So that's definitely a big one there. Just like, what is it going to take to operationalize these things? And that goes beyond just having a good model prediction.
Yeah, for sure. I have a question here, Ryan. This one's for you around. So the question is, how do you train an AI model to improve over time, which you've talked a little bit about? What are some of the best practices for ongoing model maintenance and improvement? And I might add in a variant of that, which is how do you measure model improvement? Like, what are the metrics you're looking at on the model?
Yeah. So, I mean, let me start there, actually, because that's kind of a tricky thing. So obviously, for something like a recommendation system, we're recommending something to the agent, we optimize for usage, right? So did they click on what we recommended or not? And that's a good objective function. We can train the model to sort of make predictions that agents are likely to use and take away weight from those that they're not likely to use. And so if you've set up a continuous training pipeline, so you hope the model is getting better because you're taking that information every day, every week, every month, and feeding it back in. How do you measure it? And you have to do two things. The ideal thing is do an A/B test, right? Have infrastructure in place where you can have a control group and a treatment group, and you can really measure live when the rubber hits the road. Is the model getting better, or generally any improvement to the model? This is critical and something that takes a strong data science team to get right, to make sure that you have that done right. Of course, that's expensive. You can't do that every single day because you need it to allow it to run in order to get the proper statistics to know that it's worked. So you have to think then about offline metrics, right? So how do you know, based on your new prediction, would the agent have clicked on that or not? And so, ASAP, for instance, we've focused a lot on building other machine learning models that look at those predictions, as well as what the agent ultimately did on maybe some historical data, and sort of say like, oh yes, they would have clicked on that prediction or not. And you start to get into proxy methods there, and you have a lot of, again, data science work to do to make sure that those proxy methods on historical data are correlated with true metrics. But getting this right is complicated, but this is what needs to get done in order to make sure that you're not doing something degenerate, that the model is not sort of veering off in a bad direction based on this feedback, which can happen. That's a very real possible outcome.
Gotcha. And I'm not getting pulled off stage, so maybe we have time for one more question. I kind of like ending on this question. It's about the applications. We know that generative AI can impact customer-facing solutions like chatbots, and also agent-facing solutions like Agent Assist. We have customer self-service and agent tools and capabilities. Where do you recommend prioritizing? How does one kind of prioritize where I can most effectively deploy these types of technologies?
Yeah, I mean, that's a great question. And I don't think I have kind of a prescriptive answer. I think that's kind of a value proposition. I think every single one of those, I see transformative improvements. I would say the nice thing by starting at the human agent level is you get this coaching networks effect, and then you can see the model get better, and then you can transition successes in that space towards a virtual agent or a bot, right? And start handling more of those cases. And that might be able to transition itself into something like self-serve. But of course, that would be, I would say, the sort of super happy path where I would be most confident in getting good outcomes. But, starting at any one point, I still think you're going to see transformational outcomes.
when we were looking at various opportunities, I mean, literally contact center was one of the most compelling, just because the amount of data, the amount of human interaction, the focus on business outcomes for that data, building the domain around this area that, you can accelerate that feedback loop. So
The complexity.
I think maybe one of the absolute best places to start for an enterprise.
Yeah. Awesome. All right. This has been awesome. I think I'm getting the cane. This brings us to a close for today. I want to thank our esteemed panelists for such an excellent, thoughtful discussion. Team, thank you so much. And a big thank you to all of you who joined us for the session. In case we couldn't get to your question, my fault, but feel free to connect with us at asap.com/contact. That's asapp.com/contact. And a quick heads up, we will also be sending out a recording afterwards. Thank you all again and have a great day. Thanks so much.